Hey guys, and welcome back to this video series on basic graphing here on the Turdford channel. So let's go ahead and do something. So usually when you start looking at graphs, this is usually you've seen the graph paper. I'll be honest, what you're probably more used to is this kind. Maybe it goes all the way over the paper, like there's no border, it's nothing but graph paper. This is kind of like the most common thing seems like I see in school, and that's fine. This is actually my preferred graph paper. It's called 10 division per inch paper, and you look at it and you're probably instantly like your eyes are blurring out, but I love the fact that it's got all these lines on there because it makes it very easy for me to make scales sometimes. And plus, every fifth line is a bold line. So here's what I've done. I've went and gathered us a little bit of data. And what I want to do in this first video is just take a look at how to make your scale. And then we'll go back and do more in another video. So I've got some flow rate data that I recorded using a simulation. So in the simulation, I was able to increase to see the velocity of the fluid moving through a pipe and then read how much fluid was actually flowing through the pipe. So it's a flow rate. So I've got here, the particles of the fluid are moving at 1.7 meters per second. And I've got a flow rate of 5,408 liters per second. Well, this brings us up to a good point, meters per second and liters. So when I get ready to try and make my graph, the thing I want you to think about instantly is this. Whenever you're making a graph, you should try and get units that somehow align. So flow rate is the letter Q, and you're like, I have no idea what flow rate is. That's fine. You don't have to right now. This is just a tutorial video on making a graph. But here's the problem. So flow rate is in liters per second. The velocity I recorded is in meters per second. Well, it's very hard to do a graph with oddball units. Say, for example, you were doing a graph of circumference versus diameter. You wouldn't want one of your units to be centimeters and the other meters. You will probably come up with a number that's somewhat useless. So one of the things we can do to try and correct for this in the lab, very simple. A liter, there's 1,000 liters in a meter cubed. So instead of graphing liters, let's do this. Let's graph meters cubed per second. And now look at how these units align so nicely with each other. Meter cubed second, meter per second. So I'm going to go and do something. All these flow rates, I'm going to change these. I'm dividing them by 1,000. And that way that gets those in this meter cubed per second unit. So here's what I want to do. First thing I want to do is start making the graph. So let's do something. Let's make an axis. And so what a lot of times you guys will do, the most common student axis. Here you go. You ready for this? This is what I see more than anything. Somebody's going to do this. Whoop, and there you go. There's the axes for the graph. There's two things that are wrong with this. One, you did not use a ruler, so you drew a crooked line across the paper. So deductions for that. Second is this, guys, we don't make graphs in science. We don't make graphs even with the edge of the paper. What you do is this. When you get ready to make your graph, take a ruler, move, say for example, if it's this kind of paper, you move 3 lines up, 4 lines up, whatever. You want to move the axis just a little bit over. And that makes for a cleaner graph. I'll also tell you what else it does. So here, let's do it 3 up and 3 over. And that'll give us now sometimes you'll be in a teacher's class. They may want you to do 4 graphs per piece of paper. Well, let's say, for example, you were doing 4 graphs per piece of paper, then you might end up doing something like this. Obviously, you would use a ruler. But you would, if this was the case, you should make 4 smaller graphs that look something like that. For whatever reason, I don't like doing that, but that's just me. Different teachers are different. So now this is a start to a good looking graph. Same thing if you were using this graph paper over here. one of the things you'd actually want to do is, I like this graph paper because we can actually go and check this out. This is, we can come in, let's say, over to that first bold line over, and that same thing going up. We can do that, and that gives us a nice axis. So now I want to do something. I want to start looking specifically at, let's see if we can do something. Let's remember what we want to graph. We want to graph flow rate, Q, in meters cubed per second. We want to graph that versus velocity in meters per second. And somebody may look at this and be like, you wrote on the graph paper itself. Here's the thing, that's perfectly fine. Q in meters cubed per second versus velocity on the x-axis, meters per second. You should also make a title. So let's call this Flow Lab. You need to put a title at the top and then tell what you're graphing. Like for me, this would be Q in meter cubed per second versus velocity in meters per second. A lot of people don't do this at the top of the lab, and that's, again, just bad etiquette. So now for your scale on your graphs. So let's look at our scale, 0.36. So here's what I want to look at. The biggest number is 1.8. My biggest number on this scale is 1.8. So essentially what I want across the bottom of my graph, I need a scale that goes from 0 to 2 is what I'm looking for. Well, now here's where y'all mess up. Some of y'all will go down here across the bottom, and you'll literally, like, you'll try and like mark it off like, okay, so that's a half, and then the next line you'll call 1, 1.5, 2. And so this will be your graph. 3. Here's the problem. When you make this graph, all your data is jammed in like to here. And guys, you're wasting then the rest of the paper. Again, that would be considered bad etiquette as well. So obviously, we're not going to do it that way. You want to use as much of the paper as is reasonable. So like here, what I would do is this. So I only need to get to 2. So what if I make each line 0.1? 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wow. So that would be 1. Use a different color to kind of distinguish it here. So this would be 1 at this point. My V's kind of in the way, isn't it? Luxuries. Oh, no. I didn't just do that, did I? Luxuries I have. Boom. I can just move it over. So there's 1. As soon as I put my pen back on, right? So this would be the number 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there would be to the number 2. This is great. That means each line over is a 0.1. So you got to love it when the graph comes out that easy. If you were doing this other one and you tried to do like each line is 0.1, well, now this would be our problem. We would only be using this small little piece of the graph again. So that wouldn't be the way to do it. So what you would probably do on this one is you would probably skip over like maybe, look at these bold lines across the bottom. 1, 2, 3, 4, and 5. And let's make that 1. 1, 2, 3, 4, 5, 2. And that gets us most of the way across the paper. What it does do, though, is it gives us a really wonky scale across the bottom. I kind of hate that. What we'd actually have to do is go and do like 1 divided by 25 little lines. And so that makes each little line across the bottom 0.04. Until you get really good at graph making, I don't know that you want to get too crazy like that. So let's go back for this one and let's look at this other graph. It'll be a little easier. Now, when we're looking at the flow rate, what's the biggest number we need to get to? 6. So let's go back and look at our graph real quick as soon as I get back on my graph. There we go. So when I look at my graph, I could try and do the same thing going up, make like every line 0.1. There's just one problem. If I did that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. Guys, if I did that, I would only get to like 3. That's as far as I could count. So we're not going to be able to go like 0.1 at a time. So here's what we could do. We could try and do this. What if instead of every 10th line is 1, what if we did this? 1, 2, 3, 4, 5, and said that the 5th line, there's 1. And then 1, 2, 3, 4, 5, 2. And you should be going Y. 1, 2, 3, 4, 5. So there's 3. And keep going by 5s. 4, 3, 4, 5. Counting 5 lines. There's 5. 1, 2, 3, 4, 5. By the way, if you want to know the most common place to mess up on a hand graph, it's probably counting. And so now what we have is this. We've got each one of these lines is a 5th, so that makes each one of these going up 0.2 instead of 0.1. And I encourage you guys, try and make a scale that makes your life easy. So like this would be 0.2, 0.4, 6, 8, 1, 1.2, 1.4, you get it. So we've got our graph laid out, and in the next video, we'll go through and actually put data on this graph.